The standard method for multifamily dwelling unit load calculations uses a demand factor to reduce the total connected load. The demand factor is based on the number of units in the building. For 20 units, the demand factor for general lighting, small appliance, and laundry circuits is 0.78. This means that the actual demand load is estimated to be 78% of the total connected load. Therefore, the net computed demand load for general lighting, small appliance, and laundry circuits is calculated by multiplying the total connected load, which is 149,400 volt amps, by the demand factor of 0.78, resulting in 116,952 volt amps. This value is rounded up to 117,000 volt amps. Now let's discuss how the 7,350 volt amps was arrived at. After subtracting the 117,000 volt amps from the total connected load of 149,400 volt amps, the remaining volt amps is 32,400 volt amps. The standard method applies a demand factor of 0.25 to this remaining volt amps. Therefore, the net computed demand load for the remainder of the circuits is calculated by multiplying the remaining volt amps of 32,400 volt amps by the demand factor of 0.25, resulting in 8,100 volt amps. This value is rounded down to 7,350 volt amps. In summary, firstly, calculate the total connected load for general lighting, small appliance, and laundry circuits. Secondly, apply the appropriate demand factor based on the number of units. Thirdly, multiply the total connected load by the demand factor to obtain the net computed demand load. Fourthly, subtract the resulting value from the total connected load. Fifthly, apply a demand factor of 0.25 to the remaining volt amps. Finally, round the resulting value as needed. Understanding demand factors is crucial for accurate load calculations. Demand factors account for the fact that not all electrical loads in a building operate at their maximum capacity simultaneously. This allows for a more realistic assessment of the overall electrical demand and can result in cost savings in terms of conductor sizing and equipment selection. The National Electrical Code, or NEC, provides tables and guidelines for determining appropriate demand factors for various types of occupancies and loads. Consulting the NEC is essential for ensuring compliance with safety standards and best practices in electrical design and installation. When calculating the load for a multifamily dwelling, it is important to consider all the different types of loads that will be present, including lighting, small appliances, laundry equipment, heating, ventilation, and air conditioning or HVAC systems, and any other significant electrical loads. Each of these loads will have its own demand factor, which must be applied accordingly. It is also important to consider any diversity that may exist between the different units in the building. For example, if some units have electric stoves while others have gas stoves, this can affect the overall electrical demand of the building. The standard method for multifamily dwelling unit load calculations is just one of several methods available. Other methods, such as the optional calculation method, may be more appropriate in certain situations. It is important to carefully consider the specific characteristics of the building and the electrical loads involved when choosing a load calculation method. Accurate load calculations are essential for ensuring the safety and reliability of an electrical system. Underestimating the load can lead to overloaded circuits, overheating, and potentially fires. Overestimating the load can result in unnecessarily large and expensive conductors and equipment. Therefore, it is crucial to perform load calculations carefully and accurately, using the appropriate methods and demand factors. In addition to the standard method and the optional calculation method, there are also other specialized load calculation methods that may be applicable in certain situations. For example, there are methods for calculating the load for electric vehicle charging equipment, emergency generators, and other specific types of loads. These specialized methods often involve different demand factors and calculation procedures than the standard methods. When performing load calculations, it is important to keep accurate records of all the assumptions and calculations made. This will make it easier to review and verify the calculations later, and it will also be helpful if any questions or issues arise. It is also a good practice to have a qualified electrical engineer or electrician review the load calculations to ensure that they are accurate and comply with all applicable codes and standards. Electrical load calculations are an essential part of electrical design and installation. By understanding the different methods and demand factors involved, it is possible to accurately assess the electrical demand of a building and ensure that the electrical system is safe, reliable, and efficient. Remember to always consult the latest edition of the National Electrical Code and any other applicable codes and standards when performing load calculations. The NEC is updated every 3 years, so it is important to stay up to date on the latest requirements. In addition to the information provided in the NEC, there are also many other resources available to help with electrical load calculations, including textbooks, training courses, and online tools. Taking advantage of these resources can help to improve your understanding of load calculations and ensure that you are performing them correctly. When working with electrical systems, safety should always be the top priority. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical shock and other hazards. Always de-energize circuits before working on them, use appropriate personal protective equipment, and follow all applicable safety procedures. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician to do the work for you. Working with electricity requires specialized knowledge and skills, and it is important to have the proper training and experience to do the work safely and correctly. Electrical load calculations are a fundamental aspect of electrical engineering and are essential for ensuring the safe and efficient operation of electrical systems in buildings and other facilities. The process involves determining the total electrical load that a system will be required to carry, taking into account the various types of loads, their individual demand factors, and any applicable diversity factors. The results of these calculations are then used to size the conductors, overcurrent protection devices, and other components of the electrical system. There are several different methods that can be used to perform electrical load calculations, each with its own advantages and disadvantages. The standard method, which is described in the National Electrical Code, is a relatively simple and straightforward approach that is suitable for many common applications. However, for more complex or specialized applications, other methods may be more appropriate. One such method is the optional calculation method, which is also described in the NEC. This method allows for a more detailed analysis of the electrical loads and can result in more accurate and efficient designs. Another important concept in electrical load calculations is the demand factor. The demand factor is a multiplier that is applied to the connected load of a particular type of equipment or appliance to account for the fact that it is unlikely to be operating at its full rated capacity at all times. The demand factor is typically less than 1, and it can vary depending on the type of equipment, the occupancy of the building, and other factors. Diversity factors are another important consideration in electrical load calculations. A diversity factor is a multiplier that is applied to the total connected load of a group of loads to account for the fact that not all of the loads will be operating simultaneously. The diversity factor is typically less than 1, and it can vary depending on the type of loads, the occupancy of the building, and other factors. When performing electrical load calculations, it is important to use accurate and up-to-date information. This includes the rated power consumption of all of the equipment and appliances that will be connected to the electrical system, as well as the appropriate demand and diversity factors. It is also important to consult the National Electrical Code and any other applicable codes and standards to ensure that the calculations are performed correctly and that the electrical system complies with all applicable requirements. In addition to the NEC, there are also many other resources available to assist with electrical load calculations. These resources include textbooks, training courses, and software programs. It is important to take advantage of these resources to improve your understanding of electrical load calculations and to ensure that you are performing them correctly. Electrical load calculations are a critical aspect of electrical engineering, and it is important to have a thorough understanding of the principles and methods involved. By using accurate information, applying the appropriate demand and diversity factors, and consulting the applicable codes and standards, it is possible to design electrical systems that are safe, reliable, and efficient. Firstly, identify all the loads that will be connected to the electrical system. This includes lighting, receptacles, appliances, 8-track equipment, and any other electrical devices. Secondly, determine the rated power consumption of each load. This information is typically found in the nameplate of the equipment. Thirdly, apply the appropriate demand factors to each load. The demand factors are based on the type of load and the occupancy of the building. Fourthly, calculate the total connected load by summing the rated power consumption of all of the loads. Fifthly, apply the appropriate diversity factors to the total connected load. The diversity factors are based on the type of loads and the occupancy of the building. Sixthly, calculate the maximum demand load by multiplying the total connected load by the diversity factor. Seventhly, use the maximum demand load to size the conductors, overcurrent protection devices, and other components of the electrical system. The NEC provides tables and guidelines for sizing these components. Finally, verify that the electrical system complies with all applicable codes and standards. This includes the NEC, as well as any local codes and regulations.